Thanks for coming along to Infracoders. So it's our fourth anniversary. No, it's
Next month.
next month.
4 years.
4
4
years.
years.
And so if you haven't been to an Infracoders meetup before, we have a bit of a formula. We have a couple of talks, and we have a community services announcement towards the end. And that's your opportunity to advertise for jobs or tell us about some other community thing going on. We usually kick off with a couple of words from our hosts. So please thank our hosts for tonight, REA. REA is providing the beer and pizza. It's all we here about 7. So that, yeah, we'll fit in our talks before 7. So I might hand over quickly to Colin from REA to talk about REA. And then we'll go to the first talk, Frank.
The talking stick, thank you. So, a lot of you work at REA. A lot of you have worked at REA. Some of you might like to work at REA. We do interesting things. We don't just put ads on people's ads. We do it in a different way. We do it in some interesting ways. We have some interesting challenges of scale and throughput and that sort of thing to solve. But we also like to have fun. The beer engine, which is serving the beer out there, we built at Hack Day 2 weeks ago, a week and a half ago now. So this is its second trial in anger. So I do apologise for the phoniness of it. We've not quite got the system balanced yet, but we're working on it. It's an iterative process. You can see live and running the weight sensors, which are measuring the keg weights and reporting it up to CloudWatch so that an alarm can fire and page someone when the keg runs out, except the fact that the particular network socket isn't patched in. So it's not that there's no dashboard this time, but it works. So yeah, we are REA. We do ads on people's ads. If you are interested in a role with REA and you haven't yet applied, then go and talk to me, one of the other many fine REA folks around, such as Mr. Lutz or Mason, or anyone else from REA who happens to be around. Clement, I've had, yeah, a lot of us here. So without any further ado, thanks for coming along, and enjoy.
Hi everyone. I'm giving this talk, but I can't do that until I fix this horrible typo. I'm sure no one noticed. Yeah, see? You're all very nice. I've been told there will be no heckling because you're not really that kind of crowd. Is that right? Is that a true thing?
It is now you fix the spelling out.
Yeah, okay. So we'll start there and we'll see what other spelling errors come along the way. So I'm going to give a talk. I don't actually know how much time I have. How much time do I have?
20 minutes.
20 minutes. All right, we're gonna go really fast. And what we're gonna do is we're gonna cover this topic of security, which is totally easygoing, right?
How can it be?
Yeah, I threw a TL in here because well, there's a lot of buzzwords in there. So who am I? So who's heard of Twitter? Twitter?
Yeah.
Twitter.
Yeah.
Anyone? Okay. So if you have the Twitter, you can follow me on the Twitter. I'm going to say some things you might disagree with what I have to say. Disagreeing with me on Twitter is fun for everyone. So you can do that if you like. I also have an email address that you can send your tweets to. So if you disagree with me more vehemently than just 140 characters. I say things on the internet. You can also find other ways to contact me if you wanted to, or troll me through my website. And the last time I used that joke about Twitter was today, so we're going to reset that counter. I work at Pivotal. Anybody heard of Pivotal? They send me around the world, and I'm appreciative that they do that, so that's why I'm here. I don't know if you know this, but I'm not from Australia. So I'm going to talk about general topics. If you want to talk about anything that Pivotal does, we could do that over beer or something later, but I'm not here to sell you anything. That's not my job anyway. So we want to start with some definitions. Anyone know who said, I have words, I have the best words? Trump. Yeah. I just need to make sure that everyone understands that I am not affiliated with him in case they fucking hit again. Okay. Yeah. Like, probably a smart idiot. Anyway. So vulnerability, right? Let's set some ground rules just so that we kind of understand the lay of the landscape. Who here does things with security, right? So you obviously heard of vulnerabilities, right? It's, you know, a security export. Yeah. I wrote this talk about an hour ago. Attack vector, a method to attack direct, what's that?
And then you had beer.
And then I had beer, hang on. A method of attack directed at a specific weak spot, right? So you have a vulnerability, and the way that that vulnerability can be attacked is with an attack vector. That's a method or a way to get it, right? So an attack surface would be the sum of all of the vectors that can be used to attempt to hack the system. This could be, you know, any inputs, any way to get data into a system, to manipulate its state or its environment in order to get things out. So your risk profile is sort of a measure of the criticality and the sensitivity of an application. So when you put risk profiles and your attack vectors and your surface area all together, that's kind of a measure of the risk that you take when you put things on the internet. And so this talk, I only have 20 minutes, and security is a large, deep topic, obviously. So I'm going to kind of, you know, cover the surface. And if you have questions for me, you know, we can totally dig into it. But generally speaking, risk profiling is critically important. So it's a step that you need to do. Does anyone do this like in a formal way, or try to discuss, you know, I have this application or this line of business, and I want to understand its security threat? All right, so let me give you some guidelines, right? So you need to understand what the thing does. That's important to know whether or not the risk to it being exploited is particularly important to you, or maybe not as important. How sensitive is its data, which is probably the primary thing, because while we're all talking about infrastructure and providing some secure environments, your application developers build shitty applications and expose things. It doesn't matter how good you are at providing a secure environment for those apps to run in. You still have a vulnerability and potentially exploited data. But the data sensitivity is important. If you're scoring like whether or not kids did math well, but not, you know, where they live and who their parents are, that might not be as critical. You want to know who goes to jail if it's down. So depending on the industry that you're in, you may be regulated, you may have certain expectations, you may have contractual obligations and certain liabilities for the applications you run, and your risk profile is altered by the environment that you're running in and the context that you're in. So if you're in finance or telecom or the government, you know, you've got a much higher risk profile on just about everything you do. How fucked are we if it's compromised, right? So like, how badly does this compromise end up screwing up the entire system? When you're building applications that are relatively monolithic and you're deploying them, then your risk profile tends to increase because all of the functionality is together and it's relatively co-located. So if there's an exploit to one system, it's usually pretty easy to proliferate that through the rest of the system. If you start deconstructing that, it's a little better. So who else is fucked? So not just us, but like everyone else. By the way, I tried to write these in my best Australian language, so that's why. Like, I think this is local, right? Yeah. Okay. Good. So who else is fucked when it's broken? So it's not just if our thing gets exploited, how does that affect us? But there may be proliferating issues that expand out into your network neighbors, that sort of thing. So risk profiling in the cloud is challenging because you have an application, and let's say we're going to call it a microservices architecture, and you're running it on something that is a platform. And just to dissect that for a minute, whether you're using a structured platform, like I'm into Cloud Foundry, and we could talk about that. That's a structured, fully featured, full stack platform. Or you're, you know, building on an elastic runtime, like, you know, some container technology or Kubernetes or whatever. That's sort of a platform, and you're cobbling it together on your own, or you're using something fully featured, but everyone has a thing called a platform. That's one of my things. And then, you know, then you're gonna run it in the cloud. So like, there's a lot of software in here, right? There's a lot of stuff to worry about. And there's no silver bullets keeping it safe, so we're all fucked. On the other hand, we can mitigate the risk. And I think that this is the key, right? So if I can do anything with these 20 minutes, it's to make sure that everyone here understands that security isn't about not getting hacked, right? You will always be vulnerable to exploitation. Whether or not you get exploited is generally a function of your risk profile. and how good you are at mitigating it and building a system that can, over time, mitigate incoming risk. So you have to assume that you'll get hacked, and we can use some best practices. And I'm going to kind of, again, paint broad strokes because we're talking about a big subject. So I think, and these are my opinions, so we can totally disagree, right? But I think you should build and run containers. So containers aren't secure, right? They aren't inherently secure. So don't quote me on that. Don't say that I said that. I don't say that. Containers can allow for a certain measure of process isolation, application isolation that is very, very good and brings you to a better and more secure place. You can provide resource constraints on running applications when they're running inside of a container. And you can also enforce those resource constraints. And those resource constraints are at just about every touch point surface area. And you can really start to constrain the surface area of an application when you basically cram it into a container. And then your application developers can still force you to cut corners, in which case your surface area expands, and that's a problem. But generally speaking, that's one of the reasons why I think containers are a good idea and why they're taking off. Another big reason is because there's a lot of power and safety in separating the build, deploy, and run phases of managing software, right? So anything that you're deploying and managing, you need to separate the process of building an immutable artifact, deploying it into an infrastructure, and then running. And if you keep them isolated, then that helps you avoid running code in situations and environments that you don't necessarily need to. It avoids outgoing network access to things like Ruby gems or Mavens, whatever Maven does, because I'm not a Java person. So I think that's a good thing. Also, no patch and upgrade then, right? So managing applications over time, you shouldn't lay down new files on a file system or overwrite a jar and restart a web server. That's not really a good model anymore. We know that. We know that patches lead to inconsistent state. You might have a state which appears to be the converged state that you desire, but you also have the possibility of having pre-existing state lay around that doesn't get cleaned up over time. And then you have an application and runtime environment that is not exactly what you want it to be. So by making things immutable, you kind of get around that. I mentioned reducing surface area of containers. So who's heard of Docker? Right. So I think Docker is actually amazing. And for my money, I think that Docker's design of an interface to building and running containers is the most brilliant thing they ever did, right? They built an interface that's pretty easy to understand. They've also made it more and more flexible. And some of the ways that they made it flexible, I would argue, are concerning. They're red flags for me when it comes to possible security. So we use the surface area of containers. And when we talk about that, when you've got an application, it connects ports incoming and outgoing. It has a file system. It potentially mounts volumes externally. It has other types of network access, and it also, of course, has memory and CPU utilization. It lives in the process area, and containers allow you to really constrain all that and basically isolate an app completely, and then explicitly open up endpoints. And I think it's important to explicitly open up exposure points, but open up as few as possible. I have a hard time being okay with is volume mounting, and I think that's another best practice in here. Oh yeah, it's right there. Avoid volume mounts. So I think when we build containers or we build an immutable artifact to deploy and run in production, we need to do it in a way that is truly immutable. And if you start volume mounting a bunch of volumes from a host into containers, or even if you're doing NFS to distribute, say, configuration properties across a set of applications within a cluster, I think that starts to muddy the waters, and you end up with a situation where typically your configuration, I think developers like to lie about this, your configuration is code, right? Just because you extract it from a Java app or a Ruby app doesn't mean that it isn't part of your code. It's critical to whether or not your code runs, right? One of the 12-factor principles for application developers is to expect your configuration information on the environment, right? And so if you start volume mounting things like that, then you're kind of breaking that practice, and that practice is there and keep you safe and flexible and portable. So restrict incoming network ports and be explicit about it. I'm a big fan of only exposing one port for any application that runs, so an application should bind to a port, and that is the only port that it's allowed to bind to. And I think the infrastructure we provide, the platform that we provide to run applications in, should be rather explicit about that. There are some reasons why you might want to open up other ports, but I think you have to really, really justify it. And then probably more important is restricting outgoing ports. So these are, again, broad brushes of things that you should do. So any application that runs in your environment should basically have no outbound network access except for the outbound network access that you explicitly get. So you don't have something managing that, whether it's IP tables on a host or security access groups within some other more structured solution. You need to keep these things completely isolated, right? You should default to no outbound network access, and then only open it up when you need to. And you'll open it up for things like connecting to a data store, connecting to a cache layer, connecting to a message bus, and you might open it up to connect to something, but you should be quite explicit about it, right? I think this is a really important one, and this is kind of a challenging thing if you don't have a structured way of doing this right now, but you should provide service discovery for the applications to find their backend services. So if you build a stateless app, if you build a 12-factor app that we talk about all the time, then you need to be able to provide it generated credentials and access information for its backing services. So you might use something like Eureka to do service discovery, which is fairly fully featured. A lot of folks like to use something like SkyDNS for service discovery by having very dynamic DNS, but I would argue that doesn't go far enough. You can't manage credentials with SkyDNS alone, so then you need something like Console, maybe NCP, like directly. But I actually think it's very important to separate the responsibility of who manages and holds the source of truth for application credentials for the things that they connect to. I think it's important to separate that away from the applications themselves. And right now, it is a very common practice to throw those into YAML files or have configuration management that pulls them out of a vault and lays them down on a virtual machine or into a container when you build it. And I actually don't think that's good enough. I think we need to go further. So the production environment itself should be responsible for managing those keys and credentials. You should have automated methods for being able to rotate them without developer input. That's actually a really good one. And actually the big one, and that's big, as these go down the road, I get a little ranty about human beings, but humans are your biggest attack vector, right? Almost certainly the way that you will get hacked is that somebody who works at your company will get phished, and then their credentials will get stolen, and then they'll have access to critical systems, and then you go down. And your software developers have been doing a good job the whole time, but it doesn't even matter. So the point of that, excuse me, is don't put authentication information in the hands of human beings. Hang on. I forgot to mention in my intro that before I worked at before I worked at Pivotal, I worked at a company called White Hat Security, which does external intrusion detection and also static analysis for security. I worked there for about 2.5 years, and I built their production infrastructure, their modern one. And a lot of these high-level principles are from what we did there to try and have a good secure environment. So, no hard-coded credentials. Yeah, keep them encrypted. And don't put humans in the mix. So if you've got this well automated, then you should be able to create basically the ability to have bindings between applications and their backend services that are managed by a production infrastructure. And those bindings should be able to be a source of truth to hold network connection information and also credentials information. And then when you spin up an application, if we're doing this 12-factor thing, and you have environment variables that are being provided to the application for things like backing services credentials, you should be able to spin up an app and augment their environment variables, at startup time in order to have credentials for whatever it is that's supposed to be connected to. And then that's a fully automated method of doing it. I don't have enough time to show you a demo of how it works in a system that's already well structured. So you need fully automated DNS routing, load balancing for apps. So this is, again, just basically don't put humans in the middle of deploying and managing software. The fewer human interactions, the more secure your environment will be. At least it will be predictably fault tolerant or not, like predictably exploitable or not. But when you put people in the mix, then you have problems. And when I say put people in the mix, I don't just mean manually doing checklists, because I suspect that if you're here, you believe that doing manual deployments and manual software management and manual infrastructure management isn't that great of an idea. So you probably do things like configuration management now, your puppets and your chefs and whatnot. But if you have to mess with, an Ansible, like a resource pool file in order to update a load balancer, or if you have to even like run an automation as a person or as a CI process, I think that's not far enough. I think you still have people in the mix and it's still a problem. So here's like, you must be this tall to ride this ride. So CI/CD for deploying applications. Don't let your developers skimp out on this, or you're definitely going to be deploying software that has vulnerabilities that will be undetected, right? And you won't have a way to detect them and avoid them in the future. So if you don't have good test coverage and good test quality for your applications, if that is not a part of your process, then you're kind of hosed. So who's doing like CI now for applications and deployment, where you've got tests that, so like I have people's hands up, maybe half the room, and then keep your hand up if you trust your tests. Okay, so like half or more of those people put their hands up. So you have to be able to trust your tests, and you have to have security tests in there as well. Furthermore, though, continuous delivery is particularly important. This doesn't mean that every time you push to master, you push a new version of your software out the door. But it does mean that your software is available to be released anytime anyone wants to, and that release is fully automated, right? It's a one-click or less, right? Again, this is about getting people out of the mix because people make mistakes, and part of this is don't let anyone SSH into anything. Not even you. No human beings SSH into anything anymore, right? We don't do that. The automation should be fully featured enough that you don't have to SSH into servers in order to debug them. Like, why would you do that? Or mess around with them? And if you do that, you should be able to pull them out of your production infrastructure, run them in isolation, right, and debug them, and then destroy them. Because if you log onto a machine in production, you've made it a special snowflake just by being there. You've already fucked it up, right? Whatever it is you were trying to do, you also made a new problem. Now we have to deal with that. This is hard, but I would say that this is a major goal, especially for people here. You should not have to SSH into a machine to make a modification to your infrastructure, to debug your infrastructure. You should be able to do all of that through automations that you've already built so that they're relatively seamless and easy, and that you have access controls and access capabilities to get the information you need out of the system and also put information into the system and modify it. And one example of that is that you need the fully automated log aggregation and delivery. So we talk a lot about monitoring and analytics and event management, and that's about consuming a fire hose of information. And I wish that there were more talks that I would see that are about producing that fire hose and how to do it efficiently, especially at scale, because that's a hard problem too. But you need a fire hose, right? You need a fire hose of how your infrastructure is running, how every single app is running. You need to be able to make that available to the right people, and you need to be able to lock it down so that the wrong people don't get access to it. One that I didn't put in here is don't log sensitive shit, which I think we all know. But I think it's important to say that you can get zealous about logging every interaction, especially if you have problems with compliance. If you need to do compliance and auditing for various regulations, you might want to be able to log, every modification to the system, what happened, who did it, when they did it, and then, if you're lucky, if you have a good system, you'd be able to log why they did it as well, or track it back to a ticket or something. But we have to be really careful about that because then we'll end up logging like private SSH keys, right? Or private keys between systems, or a password. So Excuse me. So we do have to be careful. And I'll try to move faster. But so we have to isolate individual network routes for application instances to the architecture. So this is especially important if you're using things like an elastic scheduler for containers, where you're starting to, I like to say, like, I can't decide which one. We're either flat packing apps into virtual machines, or we're hex packing them, but we're trying to get resource efficiencies by using schedulers for containers. Like that's I think the whole point, especially for infrastructure, is it costs a hell of a lot of money to spin up virtual machines and barely use them. And spinning them up is actually kind of time consuming. Even if it's a few seconds, it's a few more seconds than you actually need. And what we find with an elastic scheduler is that you have a pool of resources that can expand or contract, and you can start to work, deliver workloads across those pool of resources. But when you start getting multi-tenancy, even if it's trusted applications from trusted engineers, maybe internally, you need to start providing network isolation, because then you have the possibility of a bad actor, especially if an application gets exploited. It can start to learn about the other applications on that virtual machine. It might be able to learn about other applications on the network. And I think we're pretty good at being careful about host-to-host network restrictions, but we have to make sure that we're also doing container network restrictions. And there's a line from some router or load balancer down into a container that's running, and you want to be able to isolate that so a container never knows about anything else that's running around it. But then also, you have to encrypt that. So I was working for a security company. Not everybody has the risk profile that we had, but just generally speaking, don't assume that if you have a firewall that everything is fine, right? I mean, everyone knows that, right? Like if you lock down your perimeter, if someone gets in, then you're still fucked if you're not secure in between it. And this is hard because whenever you want to do something like deploy Redis, but you want encrypted connections between Redis and all the applications, then you have to build tunnels between Redis and all the other stuff, and then you have to do that even if it's on a local host. You can do that with IPsec or other tools. But I think that's actually critical as well, because the data transfer also has to be encrypted and secure, right? So just because you encrypt your data at rest, if you transfer it in the clear, it doesn't matter then. And if you don't keep it safe through network transport, even internally on a host or across the network, then that's no good either. So you have to be able to provide a system for your developers or a system for your engineering teams to deliver code that transmits sensitive information, but transmits it securely and encrypted. All right, let's see what else. So automated upgrade strategy. So this is really about mitigating risk, right? If there's one thing that I would encourage you to automate, it's to be able to move forward with security patches and revisions of operating systems. And some of this requires you to also extract away the operating system specifics from your application developers and the applications they build. So there are also runtime environments that sit on top of OSs for running Ruby apps or Java apps or Node apps or whatever you've got. But you need to be able to do rolling deploys fully automated. Otherwise, you're going to skip a CD, or you're going to skip a major release of an operating system. So how many people are on your favorite OS and you're on your latest and you've got all your security patches? A few, okay. And then how many people had to do that over a weekend with like a maintenance window and downtime? Yeah, so like you shouldn't need that, right? And really that's about reducing the risk of making change, right? So a huge thing about security is just staying up to date. And if you can stay up to date, you can do it easily, and there's reduced risk, and the business isn't scared, and you're not scared, application developers aren't scared, that's probably the biggest thing. So this is like, I think, my last one. So I'm not going to talk a lot about hardware. I don't work for a cloud provider. But if I had to pick how to run my software, especially for security, I would pick a big cloud provider with a lot of money and a proven track record. That's what I would do. So security is risk management. It means time to recover. We start with that. That's for security too, right? So if you have an issue, or if you have a breach, or if you know that there's an exploit that's possible because you have a great security expert, you got to go fast. Security is making the right thing the easy thing. All right, final thought. Your 5-person team isn't going to be Amazon's army, right? Like your ops team is bright and they're smart and that's great. And there are problems that they can definitely solve. But they aren't handling the level of attack and doing it as well as Amazon. Just as an example, or Microsoft. I don't know how people feel about Microsoft, but seriously, Microsoft has this shit down, and they've got a lot more people on it than you do. Or me, my company. And it's adorable if you think that you can, right? The point of this is that the stack is big. We talked about that. You've got infra and platforms and runtimes and frameworks and applications. And that's a lot to manage, and it's really hard. So what I would say is that for as much as you're able, stand on the shoulders of projects and people who have come before you who have done a lot of work, and take advantage of their engineering expertise and use it, and then automate ways to keep that up to date and keep it running well. Yeah, so you need help, right? And that's kind of the end of it. And I don't know if we have time for questions. I probably went over. We do?
Yeah, let's do questions.
All right, let's do questions. So that was a whole lot of stuff, basically up and down the entire stack. Does anybody think that I was full of shit or stuff like that? I said all the right things. No one disagrees. There's nothing more to say.
Just mic drop.
Yeah. All right, that's cool. I mean, thank you for your time and attention. If you want to dive into anything in particular, these are my opinions. There are other ways to be secure and provide secure environments, but at scale, it gets harder and harder. So don't let people SSH into things and keep your shit updated. That's it.
Okay.
A quick question about putting automation around security testing into the CI process. Got any tips on that? That sounds cool.
Yeah, we should do that. Right. So when it comes to automation for testing in the CI process, there are providers like Qualys and Veracode and the company that I used to work for that do automated testing and have interfaces and APIs that you can interact with. The biggest thing is automate everything that you can within the CI pipeline. The thing that I hate the most is any manual testing that goes in between deploy and development for anything that you can't. All right, let me back up. You should be able to identify which changes to a piece of software or an infrastructure represent a change to your risk profile and your attack surface. And you should be able to call those out. And then you should also be able to identify the ones that don't. When you're changing a link or a title page or a color on a website, what are you doing if you're running that through a manual security process and audit process and QA process? Like, why are you even doing that, right? So I think it's important to be able to identify that and be able to have a business process that can bifurcate. So there will be some processes that you really need to do, like some heavy pen testing. So you got an update, you build a new feature, you build a new app or something. You're going to pen test the shit out of that, right? You're going to go to town and try and break it, and you should do that. But for minor things, you should still provide a level of automated testing. Each environment does different things. So I know in the Ruby ecosystem, you can use Breakman to do some manual, or to do some automated static analysis of your source code. I believe that Java and Node and some other environments have similar things, but I can't name them. So everything you can automate, I would say automate it into your CI pipeline. Like you want everything to go green as much as possible. So it's not just unit tests, integration tests, performance tests. You should have security tests there. But also a security breach is a defect in production that needs to be addressed, whether it's infrastructure or in a piece of software. And you need to be able to address that and write a test case for it that fails if it ever gets exposed again, right? So this is more about general engineering practice, which is that you should have a test case that fails if you expose that breach again. Because if you expose it again, if you make that same mistake, you have a developer that didn't learn, or an infrastructure person that didn't realize what they were doing, which happens all the time, you should be able to catch it in CI/CD. That's my big thing. And if you don't, it's a regression. I don't think the regressions are really all that acceptable. So. But I'm kind of a pain in the ass about that. Is that good? All right. Thank you again. Thank you so much.
Well, Shane gets set up. Okay.
So Colin's providing beer as a service. If you attract his attention, he'll probably bring beer to you. Look at the back. How's that?
It's a simple beer service.
Beer as a service. I think this is the first word in my code.
I believe I've almost got the system.
Beer comes to you.
This time, sure.
Yeah,
Yeah, you do.
I'm doing a bit now.
Sorry, I'm washing your window. You don't have it. You want to talk? Yeah. You just need to speak, so you need one.
Anyone else?
I'll come back.
Maybe about 2 minutes.
You don't scale very well.
I don't scale, no.
I'm on demand.
I am not self-service. I'm not self-service. All right, who else on that side?
And the pronunciation.
This one should say nearly as long.
So our second talk tonight is by Shane Bollicino. She's going to talk about Azure. Who's using Azure?
That's what I want to know.
Hey! That's counted half a dozen. There are other clouds. Who had the big news today?
Yeah.
No. Microsoft SQL Server on Linux. Are we excited?
It's Infracoders stand-up routine. And you can run mono as well on Linux.
Right, who did I miss on this side? Who missed that?
Is there a -- quiet flag for the beer distributor?
No.
So, firstly, I must apologise for this. It definitely doesn't look like this before the red circles on my screen. So hopefully it is visible when we skip out of PowerPoint and into the demo later. So first, hi, my name's Shane, and tonight I want to talk to you about automation and scale on Azure using templates. If at any time tonight you have questions, feel free to jump in.
Close to the microphone.
Done. Okay, so who am I? Before I get started, prior to my current role, I've lived and breathed online for probably the last 15 years, from running a hosting company with 200-ish physical servers to looking after around 10 to 20,000 domains, to my time spent at sea. Who here knows of Synclot? Well, more than what I would expect. So for those who don't know us, we're Australia's largest food manufacturer. And on average, you've probably eaten one of our products here today. Given that, we have traditional infrastructure, and HTTP and the likes of online are probably seldom buzzwords that are flashed about in the office today. And I love automation. Inside work, outside work, I am really passionate about automation. So onto Azure. So many of the talks here are focused on AWS. I've lived with AWS for the last couple of years, and tonight I'm not here to convince you to ditch AWS, because it's a great, capable platform. But what I want to convey is that if you want to do infra as code and you're a Microsoft-centric shop, you probably want to embrace platform as service offerings more than infrastructure as a service, and you have limited development and DevOps capabilities, that it may just be, the solution that you're actually looking for. So we just had some hands up a moment ago on who's using Azure. How many people are using Azure have heard of ARM? All right, far more than what I thought. Okay, bear with me. All right, so if you've been using Azure, you may have noticed that probably up until late last year, there were two portals. We had the legacy, nothing too great, the standard Azure portal, which was based on a REST-based API, and we've now moved to the preview. This is the current portal, it used to be a preview portal, which is based on something called Azure Resource Manager, or ARM. So Microsoft introduced this to simplify deployment. It's all done via reusable templates, and we all know the benefits here of what templates can offer. All right. What about Azure Stack? Is anyone here playing with using Azure Stack? Wow, amazing. So ARM obviously also powers Azure Stack. ARM is really the API layer for Azure V2. All services that are resources that you want to build inside Azure that are version 2 compliant can be manipulated via ARM. So onto ARM. A few things to keep in mind when using ARM. So obviously it's template driven. It is an API first strategy. There is nothing that you can't do in Azure that's version 2 that you can't manipulate from ARM. So that's from setting up your virtual machines, your VNets, your express route, like the direct connect equivalent. Everything can be manipulated via an ARM template. It's declarative, so you declare the resources that you want to have rather than imperative. It's idempotent, which is great, so you can just run the same script over and over and over again. I put multi-service up here because unlike AWS, Microsoft had this annoying trait of pushing services and functionality out to Azure that may only be available in North American data centers. Australia seems to lag, so at some point in time last year, ARM wasn't available in the Australian regions, but it now is, and it's available everywhere. And it's extensible, so you can link it to PowerShell, Chef, Puppet, DSC, etc. So all this must sound familiar. It is basically Microsoft's equivalent of cloud formation. And it's all JSON based. So now I'm just going to dive a little bit deeper. I'm not going to go too deep tonight into the structure of these templates. So obviously they're JSON. You can use any editor that you like. I find Visual Studio probably to be one of the best tools, not because it's a Microsoft tool, but it understands Azure. So it provides IntelliSense, for native authoring. And if you need to deploy to Azure, you don't even need to sometimes hit the command line or log into the GUI. You can do it all in there. So with the structure of an ARM template, there are a few fields that are required. So obviously the schema, which does get updated from time to time. It's a really old line in here, but it dictates the version of a template language. So the content version, we said Casey before talking about incrementing your infrastructure. You can obviously increment your template version, redeploy, it'll figure out the changes, blow your old stuff away if your script is set up that way, and move forward. Parameters are values that obviously pass, variables. The resources here are actually what you're building. So that could be your virtual machines, your storage account, your networks, and so on. And outputs. So these aren't required, but you may want to be able to return something from a deployment that a Chef, a Puppet that can carry on after the deployment has taken place. for the purpose of everyone wants food, I'm not going to dive any deeper into what I've just described. We've probably all seen cloud formation a million times here. One thing which I find quite helpful is you can do linked templates. So, obviously you can decompose your deployment to sort of targeted purpose-specific templates. So you can, just like put your application number. There are many benefits. So you can have your main template, which calls parameters, resources, and so on. They can be like a file, but it's quite common to just use a URI. There are heaps of templates on GitHub, probably more than anything else. So you can hit GitHub, Visual Studio Team Services, S3, Azure Table Storage, and etc. Okay, I might just quickly flick through to Visual Studio here. Can everyone see this? Or does it need a video? You're good? All right. So, as I was saying before, why I like Visual Studio is really apologize about the projector. There should be icons against everything here showing the icons of the Azure service. Actually, here they come. There we go. So, it's a great way to be able to easily visualize what is happening inside Azure, and you can deploy directly from here. So, I think this template here is a 2-node Linux front end with a SQL server on the back end. So obviously, you have your schema, your content version parameters, the variables that you're going to pass through, and the resources on what you're creating. I haven't used AWS probably for at least a year now, and I'm not sure if it does support it. I'm sure that will tell me or not. Everything you deploy via ARM is deployed in parallel. So if you're spinning up 100 servers or you're spinning up 10 servers, it's pretty much exactly the same time it takes to deploy, which is pretty neat.
Does it do dependency resolution? So dependencies between servers?
Can you elaborate on that first?
So if one of your servers requires another server or some other resource in another, some other attribute of another resource, that has to be done first.
It figures that out. It will validate the template.
Okay.
Unless you put the -- force when you execute it.
Yeah.
All right. Might move this. I may explain why it's not coming up. So deployment. Tonight I'm not going to focus on anything other than command line. So you can deploy directly through the portal, through the Azure Quick Start Gallery, which automatically locks you into Azure. And the main way is that most people here probably deploy is either via Azure PowerShell or the cross-platform CLI. Is anyone here using cross-platform CLI? Excellent. We'll get to that in a minute. So installation of Azure PowerShell is pretty simple, and I'll put a link to this at the end of the deck. If you've had Azure PowerShell installed previously in the past, you need to uninstall it, and you must be on version 1 or greater to leverage ARM. Documentation on the Microsoft website, to be honest, is pretty crap. Often doesn't reflect the latest changes that are happening on the Azure platform. So, it's a very simple deployment structure. You hit that commandlet, give it a deployment name, what resource group, which is like a container, a template file, any parameters, and so on. So I'm just going to spin something up just to show you how simple this is. struggling here a bit. Alright, so what I'm pulling down here is being pulled directly off GitHub, so hopefully it still works. Right, so here I'm not using a parameters file.
Password 1, 2, 3, 4.
Yeah, unfortunately, password requirements are often really tough, and password 1, 2, 3, 4 will just fail with lots of red. Give it. So hopefully that should go away and do its thing. Probably only take, I'd imagine, about a minute to spin up. This is only spinning up 1 VM, and should be really simple. Okay. So cross-platform CLI. So as the name implies, it's obviously going to run across platforms. I've had a play with this, and it actually works really good. Probably easier to deploy on Linux than it is in PowerShell. There's a lot less stuff that you need to type in. It will work on Mac. There's a DMG available. On Ubuntu, it's just as simple as using npm. So once npm is installed, it's just npm install Azure CLI, and away you go. You can also run this on Windows. It is meant to be as full-featured, and maybe there may be use cases when you're lots of different types of end-user environments that may be beneficial. But for the majority of my dealings, I'll just use the Windows PowerShell functionality. So ARM-Viz. For those who are using PowerShell, does anyone use ARM-Viz? So ARM-Viz is a GitHub project. It's actually really cool. You can either pull down existing ARM templates from the gallery or upload your own, and it'll actually draw your infrastructure out based on the JSON template. You can then double-click on images or pictures that it's drawn, and it will show you the specific set of JSON behind that picture. So I might just bring that up. So obviously you can open your own existing template. You can load the Quick Start template. So these are synced from the Microsoft gallery. Not that often, but often enough. So here 2 VMs, load balancer, SQL, port address translation, security groups, and so on. And it will draw this. So I find this helpful for where I work. We have really traditional infrastructure. Infra as code is a foreign term to a lot of people, and this is just a way to be able to visualize the code, bring it to life for people. So if I click on the load balancer, it will show the JSON behind that, the port address translation that's occurring, and so on. You can also draw stuff on here and then export it out as JSON. It doesn't do validation, and it probably suggests you probably stick to your favorite JSON editor and munch together other people's templates to get to do what you need to do. What would be really cool if you could export this out as a video diagram or some form of flat file. probably clicking doesn't help when. All right. So tools of the trade. Visual Studio, if you have access to it, use it. It's expensive, there is a community edition. It is still pretty full feature baked. There's also Visual Studio Code, which is Microsoft's open source project. It has native GitHub integration, so it's really good in that aspect. The Azure Quick Start templates are a gallery, kind of like I want to say Amy images, but they are JSON templates to do everything from bringing up an express route circuit or setting up a VNet to building a Docker Swarm farm on Ubuntu. Or there are hundreds of templates out there. Atom, Notepad, I spoke about ARM, and then ARM Resource Explorer. So that's all I have tonight. I'll post the deck up, probably on the Infracoders, probably on my blog, and then put a link on the Infracoders website. I blog probably extensively on building control systems on automation, which these days is influenced extensively by code. If you have anything deeper that you want to talk about in regards to ARM, I'll be hanging around tonight, or you can contact me on any of the details above. Thank you, and does anyone have any questions? Or are we all hungry?
So the video before had the thing with the nick on it.
Oh,
What does that mean? That, yeah.
what does the NIC mean?
Nick, yeah,
It means
nick
virtual
on the
machine relies on the NIC, which relies on the network, and so on, to show the dependencies between them. So,
You're going to go back to the demo.
oh yeah, how'd it go? Hope it worked. It did work. There we go. So no red. Probably would have taken, I'm guessing, probably about 1 to 2 minutes. It's generally really fast, and it runs in parallel. And I hit the up key and do it again, and probably figure out I'm trying to do the same thing and redeploy in seconds. So the mode there is incremental. It will change depending on what you're trying to do.
So when you reference the external
Yep.
like GitHub or S3, what options do you have for securing it?
I don't know, to be honest. I'm guessing you may be able to do like basic auth or something like that. All the URIs that I've access templates on are all publicly accessible. I imagine if you probably keep it behind closed doors if you did not want them to be publicly accessible.
Any other questions?
Any more?
No.
Thank you very much.
Thanks, Shane.